Hi everyone. Today we are going to see the purification of lipase from Staphylococcus caprae. The Staphylococcus caprae was isolated from the oil contaminated and was found to be lipase producing. Lipase are hydrolysis enzyme which break down the lipid into fatty acid and glycerol. What happens is lipases acts on ester bonds between the carboxylic acid and alcohol. It is widely used in the various areas such as industries, including food, pharmaceutical, biodiesel manufacturing, detergent, cosmetics, and various chemical manufacturing. The different separation techniques used. Firstly, ammonium sulfate precipitation, gel filtration chromatography, ion exchange chromatography. When the cell is lysed and centrifuged, we get a crude extract which contain a number of proteins. To exclude the undesired protein, we have to perform a series of purification method to get lipase as a pure form. Firstly, we have performed ammonium sulfate precipitation. Ammonium sulfate precipitation is a selective precipitation of protein so that it precipitate out proteins. The key mechanism behind this is salting out the hydrophobic interaction between the protein and the water molecules. Since the salt ions also react with the water, the randomness increases. This is a high entropy process. The main concept behind the protein precipitation and solubility is the salting in and salting out. When a mild concentration of the salt is used, the salt ion reacts to the proteins and the H2O adhere on the proteins, increasing the solubility. Thus, salting in is used for protein solubilization, while in salting out, high concentration of salt ion is used. What happens is high concentration of salt ion, instead of reacting with the protein, it reacts with the water. Thus, no atom of free molecules are there, and thus protein precipitate out. The ammonium sulfate is used because ammonia has high ability to precipitate out proteins from the solution. Gel filtration chromatography. Gel filtration chromatography or size exclusion chromatography is a chromatography method which separate out molecule based on their size. The gel filtration chromatography has a stationary phase which is porous in nature. What happens when a sample contains a larger molecule and smaller molecules? The smaller molecules enters to the pores and the retention time of the smaller molecule is very high, and the larger molecule, since that cannot enter the pores, they separate out early. The graph shows the blue line, which is the larger molecules, and a red line, which is the smaller molecules. Here we can see that the larger molecule is excluded earlier than the smaller molecules. Anion exchange chromatography. It is an ion exchange chromatography that separates out molecule based on their net negative charge. Since lipases have a negative charge, the stationary phase here is used is a positive in nature, so that the lipase reacts and adhere to the positive charge. The compound here used is diethyl aminoethyl. Since amino is positive in charge, react with the lipases and lipases get separated out. HDS page. HDS is a detergent used to denatured proteins. It disrupts the non-covalent bonds between the proteins and give them a net negative charge. The HDS page contain two gel, the stacking gel and the resolving gel. The main difference here is in the pH. The pH of the stacking gel is about neutrality, that is 6.8, while the resolving gel pH is 8.8. Also, the pore size of the stacking gel is larger, while this resolving gel is lower. The polyacrylamide gel is made up of acrylamide and bisacrylamide. The pore size can be changed with the increase or the decrease concentration in the polyacrylamide. Since we added HDS page, there is a net negative charge on the protein. After loading the sample and an electric gradient is applied, the protein starts separating out on the basis of the size. Here, while loading, we add some organic solvent like chloride and the glycine. The main reason is to stack them in it because the order in the stacking gel is chlorine, then protein, then glycine. This helps to stack the protein in a same line. While in the resolving gel, since glycine is a deuterionic ion, it got a negative charge, and the order in the resolving gel is chlorine followed by glycine, then a protein. This helps to get a distinct band of the protein. The unstained page can be stained by using chromacy brilliant blue and compare with the marker or the ladder. Now let's see the result and conclusion what we got. The purification profile of the lipase eh, shows that the specific activity of the lipase is significantly increasing while the total protein concentration significantly reducing. That's how we separate out lipase by following a series of purification techniques. The HDS page also show the purity by giving a single band of 87 kilodalton. Thus, after purifying the lipase, the molecular weight was found to be 87 kilodalton. The biochemical assay showed that the lipase was excellent enzyme for biotransformation in the food and pharmaceutical industries. That's how we end up here by purifying the lipases. Thank you for watching.